Good morning, everyone. Welcome to our webinar 3D Across ArcGIS. So, when we say 3D, we have a question like why 3D? So, let us start with that itself. So, why 3D is important? Like, when we think about that, we have this, like, it gives us the view and understand in the context, like what exactly there on the ground. We can see that in the 3D in the GIS, and we can visualize the things which they might not exist now. We can create them and we can visualize that, and we can create the analysis or the behavior or how the aesthetics it is going to give to our environment or our city. And it is the best way to communicate with our non-technical stakeholder. We can explain the things with the actual view. Okay, this is going to be there, or this is how it is going to affect the things, and it gives us a more accurate representation of the real world also. And also, it is not just in one particular domain. 3D can be applied everywhere. It can be in the engineering domain, it can be in the GIS where we deal with imagery or elevation, or anywhere we can apply this. It can be the HLS use cases, it can be urban use cases. So everywhere 3D stands out, and it helps us in doing all these things like communication, visualization, and aesthetics, and real world accurate representation. So now let us take an overview how 3D is in ArcGIS environment. So let's start with the desktop part. We have these offerings like ArcGIS Pro, which is our GIS desktop offering with 3D analyst, and we have ArcGIS also, ArcGIS Earth, and ArcGIS City Engine. And moving to the web part, we have ArcGIS Enterprise. In ArcGIS Online, we have multiple options like Scene Viewer, Instant Apps, Story Maps, Experience Builder, and ArcGIS Solution, and some specific applications also for indoor. ArcGIS Indoor is there, then ArcGIS Urban, GeoBeam, and 360 VR. And parallelly, we can see ArcGIS Reality is also there, which will help us to create the foundational data for the 3D. And when we move to the customization part or the developer option, we also provide all these flavors in the customization like ArcGIS Pro SDK, City Engine plugins, and ArcGIS Earth API, and other REST APIs and SDKs. Now let us concentrate on something more, which is the digital twin or the trend in this decade. So 3D is actually fueling the digital twin when we want to develop a sustainable digital twin for the planning or the designing or any other purpose. So when we talk about digital twin, it is majorly having 5 pillars. First part is the data capture, then the analysis on that, where the ArcGIS system is coming, and SDKs and APIs for the customization, and obviously real-time data to integrate what is happening on the ground. And finally, all these things attribute to your applications and solutions. So let us concentrate on the data capture part, which is our first pillar. So when we move to the data capture, we have multiple options. So let us see what all are those options. So in ArcGIS system, we can dynamically integrate multiple types and formats of data. So these formats can be anything, like we support 150 plus formats and different platforms. So your platform can be satellite, aerial, drone, or any other. And we can have different formats also. It can be multi-dimensional, multispectral, LiDAR or radar, etc. And these things also supports in the service format also. Sometimes we take the service options of Landsat, Sentinel, or World Elevation, and these are available in the format of in a curated format in Living Atlas also. So these things are supported, and particularly when we say about this data capture, when we do that and when we have these imageries in hand, we need to process that. So that is where the power of ArcGIS Reality is coming into the picture. So in ArcGIS Reality, it supports all the 3 platforms, which is satellite, aerial, and drone, and we can use that to process and manage this input imagery into 3D meshes, point cloud, elevation model, and true ortho. And once this is done, we can take that into the ArcGIS environment for analysis and sharing. So when we talk about ArcGIS Reality, we have this question, how we exactly going to use that. So there we have multiple options. We can have desktop or SaaS option, and we can have multiple flavors, like when we do for different scales or extent. So we can have ArcGIS Reality for ArcGIS Pro, or Reality Studio for your city or countrywide mapping, or for small scale things like site mapping, and for all we can use site scan for ArcGIS or drone to map. where we use mainly drones. So that is how we do the data capture part. So now moving on to the next, which will be our ArcGIS system. So let us see how 3D is in our ArcGIS system is performing. So when we say ArcGIS system, the first thing which comes to our mind is ArcGIS Pro, which is the desktop offering. And in that we do support 2D maps and 3D scenes for the visualization, and we have voxel layers for these continuous data, and we have now introduced time enabled scene layers, and we have multiple analysis options also, which includes weave shed, line of sight, etc. So now let us quickly go to a demo how these things are actually working. So first I would like to introduce our 3D base maps. So now you can see ArcGIS offers a variety of 3D base map along with our 2D base map. So you can choose among these things and you can play around. And you can select from these 3D base maps and you can start your 3D workflow from here itself. And as I mentioned, the new add-ons time enabled scene layer. So here we can see a area of Hyderabad and how this time enabled scene layer is working. And you can see with the time attribute how the area is growing or how the new buildings are coming up. So the use case may differ, and how this is how it is working. And as I mentioned, we support different formats, and also for an example I am showing here how I have integrated a BIM Revit model into the ArcGIS environment. So I can georeference a BIM model and make it location aware of the location, and I can place that in my area of interest, and it is directly supported. So when we move to the analysis, we have direct options of exploratory 3D analysis, which is coming with multiple options like cut and fill, elevation profile, line of sight. So let us just try a view shed analysis over here. So we can have a view shed analysis, and it will give you, okay, which these many areas are visible and the pink area which is not visible. So like this we can do multiple analysis over ArcGIS Pro. And ArcGIS Pro with 3D analyst, it also comes with other various options for the analysis. Now moving back to our presentation. So we have seen the desktop capability, some of the desktop capabilities, and we saw some of the scene layers also. So in the scene layers, we have seen how the 3D objects are coming, and apart from that, it do support point scene layers, integrated meshes, point cloud, and we saw the building scene layer and voxel scenes are also supported. So now let us see how these things are coming in a WebGIS environment. So we saw these things in the desktop. Now let us see how it is coming with the WebGIS environment. So in the WebGIS environment, which when we say we have seen the BIM data in the desktop, now I can take that into my WebGIS also, where I can either use in ArcGIS Online or Enterprise. And when we convert these BIM models into a building scene layer, we can actually deal with the layers, or we can deal with a particular floor of this BIM also. So likewise, we can interact with this BIM layer, or we can create applications on top of this BIM layers. So likewise, I'm having a separate application here for my building points. So here you can see my buildings in the scene layer, in a web scene layer, and you can actually interact with scene layer. You can see how the flood in this Mumbai area is affecting. By just playing with the layers, I can understand these things. And on top of this, we can also do analysis on top of this, and we can have visual representation how the cloud cover is going to work on this area, or how the rain is going to affect these things, and these kind of things also we can do over a scene layer. And we can do a daylight analysis, how the daylight is going to affect this area on a particular date and time, or how it is continuously affecting the sun position, or these things, the shadows. These all analysis is possible, very much possible on the web. And as we mentioned, the voxel layers, so here we can see an example of voxel layers or soil voxel layer, where we have some borewell information also. So with this voxel layer, I can understand what is the soil profile of this area, and even I can do some of the analysis option also here. So I can do a slice here, and I can check what is the soil profile inside. So it is pretty straightforward, and we can understand and analyze this kind of profile data. It can be a soil profile, or it can be a pollution data, air pollution, or anything else. So that is how it is helping us to do all these analysis in the web also. So we have seen some pretty interesting things in the desktop capabilities and in web. So now moving on to ArcGIS City Engine. It is also a desktop offering from ArcGIS, where we can model the 3D cities, urban environment with the procedural capability. So ArcGIS City Engine is basically working with computer generated architecture, where we can do procedural modeling of basically urban areas. So let us directly move to a live demonstration how this is working. So here we can see our ArcGIS City Engine, and you can see a scenario wise comparison also. These things are possible in City Engine, and in the first scenario you can see a thematic representation how the buildings are supposed to be the use type and all. And in the second scenario you can see how I can model that. So I have modeled these things with the computer generated architecture rule or CGA rules, which is available in or the capability of City Engine. So here you can see the rules I have used here in the left hand side, and you can model anything or everything. As we can see, we have modeled trees, we have modeled buildings, we have modeled streets using the capabilities of ArcGIS City Engine. And sometimes we feel like, okay, what to start to model our city. So in that time also ArcGIS City Engine comes to your rescue. We can use the get map data option, and we can just start by this itself. We can search for our area, and we can select from different base maps, and we can just set the extent. And once that is done, we have different high resolution base maps available, and we can directly download the SD World elevation along with OpenStreetMap network footprints. And the best option is you can actually generate models out of this, where we will be getting the models like these, the streets and the buildings. So this is how you can utilize the capabilities of ArcGIS City Engine when we want to start with a city modeling. So now we have seen the modeling capabilities, but apart from this modeling capabilities, ArcGIS City Engine is also enable us to do advanced analysis also. So let us check a viewshed analysis. So in this viewshed analysis, we can see the traditional way of representation, the green and red, which area is visible, which is not. But apart from that, in the right hand side, you can see a photorealistic view, what is the view from that point, and you can have the percentage of these many layers, this much percentage is visible to me. And it also comes with the integration, direct integration option to ArcGIS Urban. And apart from that, whatever we create in ArcGIS City Engine, we can export these models in multiple other options for other industry specific softwares. Like we can export that into Python format, KML or Autodesk format, or S3 scene layer package for the use in ArcGIS environment itself, or file geodatabase we can convert. Or if you are an Unreal Engine user, you can directly connect your Unreal Engine game launcher from here, and you can take this for the simulations there. And apart from that, you can always convert these models directly into the entire scene layer. Directly you can convert into a 360 VR experience or mobile scene layer also, where we can further take this into other application and give a better experience to our stakeholders or the users. So that is how our City Engine is helping us to do our analysis and further things. But apart from that, sometimes we feel like, okay, I'm not much familiar to City Engine, but I'm familiar to other industry software. So for them, City Engine comes in various flavors like plugins and extension. So ArcGIS City Engine for Urban is available as a ArcGIS Urban suite, and for AutoCAD Maya we have Cerelio, and likewise for Rhino, Puma is there, and the list goes on. And specifically for the developers, it is available in a SDK version of the C++ also. So now moving on, so we have seen the modeling capability or 3D creation and desktop capabilities. Now the next part is our SDKs and APIs. So we have seen everything out of box things. Now there will be people like where we want everything in our flavor, or we want something on very specific way. So that's where we can use 3D in SDKs and APIs options. Like we have all these things available in a customizable way, like ArcGIS, Earth Automation API is available, and as mentioned before, we have the SDK for ArcGIS Pro, and for City Engine we get it in a C++ flavor also, and we have options of the JavaScript of web configurable application we can do in a JavaScript version, where we can develop our custom applications, and we do provide the options of runtime SDKs, game engine SDKs and all. So all these things, whatever we develop or whatever we customize, we can integrate that with our ArcGIS environment, where we do our configuration, customization. All these things can work together and we can enhance our experience. So here I am having an example of the same, where you can see my colleague used the model I generated in City Engine, and he's taking that into the game engine. So in the game engine, he's simulating and see how this area will look if it is getting flooded. So you can see how it is interacting with the flood water, how the pillars are interacting, those things he is testing. And we can also see do the simulations for the simulation, like if it is rains or if a vehicle is moving, all these simulations. So we can model everything in the ArcGIS system itself, and we can take that into the formats which game engines or any other software supports, and we can develop furthermore on top of this, and we can do the simulations like this. So that was about the SDKs and APIs. Now the fourth pillar of the digital twin or the system of 3D is the real-time data. So it's not in the 3D system, so we are just skipping for now. So the fifth part is the applications and solutions. So in the applications and solution, first one, I would like to introduce some applications, very specific applications, and our web applications also. So as I mentioned, very specific application, first one is ArcGIS Urban, which is specifically for our planning and designing of our smart cities. So when we say this planning and designing, this comes with a 3D flavor. We can do all these planning and designing in 3D. It supports scenario-based planning. We can have stakeholder public engagements in this, and we have inbuilt dashboards also in this. So now let us have a demonstration of the same, how it is actually working. So here you can see my ArcGIS Urban demonstration, in which you are seeing a scenario 2 of a residential zone, and in the background you can see the representation of my zone layers, and I can have multiple scenarios also here, and in particularly you can see how I have developed my 3D buildings over here, which is giving me the space use scenario and building type, this kind of understanding. And on top of that, as we mentioned, it is having a dashboard, inbuilt dashboard, where we can actually configure our own equations, how this planning is going to turn out in the future, how it is going to attribute to the number of jobs or population going to be served, or the CO2 emissions, and we can actually compare this dashboard from scenario to scenario, and this helps us to understand or identify which is the best things to go forward. So like from here I can select, okay, this one is like more sustainable plan, and this I can engage with my stakeholders also. So here you can see I have the option for the discussion. So here I can open this my particular plan, whatever I create in ArcGIS Urban. This I can open for public if I want, or I can only open for a particular team, or I can open it for my entire organization. So here you can see I have just opened this for my urban planning team of HMDA. So this was the area under HMDA, and they are asking me to accommodate the changes they are suggesting. So here we can actually, in the location itself, they can pinpoint and they can ask us to do, okay, do this kind of a change to this particular plan and it will be better. So this kind of changes they can suggest to each and every scenario, and we can accommodate that on the go. It is not like we have to build it from the scratch again, as we do in the traditional way, where we do the paper modeling and all, and that there we have to scrap everything if we need to accommodate a change. So here we can directly do these kind of changes, and on the go we can update the plans, and we can finalize one between these scenarios, or even we can create a new scenario based on a particular scenario and move forward like that. So it is like on the go, we can do all the change accommodation and everything. And apart from that, here we can have the measurement option, how the buildings are under the law or not, this kind of measurements one can check. And here also we can interact with the sun position by date and time, how the shadow is affecting at this particular time. All this kind of analysis is very much directly possible within this ArcGIS urban ecosystem itself. And we can also set different viewpoints for the stakeholders, where they can just particularly select and they can see, okay, this will be the view from this side, like that. Now, so that was about ArcGIS Urban, and as I mentioned in City Engine, we can have a direct integration of ArcGIS Urban in the City Engine also, where actually we saw a plan which I created in ArcGIS Urban only, where we modeled it for the further engagement. Now moving forward, we have seen ArcGIS Urban from the planning perspective. Now once the planning is done, the next part is the construction. So there we are accommodating the engineering fact. So basically nowadays construction stand alone, where all the engineering activities take place, and basically they do that with building information model or BIM, where they have all the information on their engineering document or engineering things, everything. But then there is GIS, where we have all the other information, what is around that building or the construction area, how the natural environment is, or the context is. Now when we have these all two things in a different perspective, they don't go together really, right? So that's where we are integrating that with a collaboration. So to integrate this BIM and GIS in one go, we are collaborating with Autodesk Construction Cloud and BIM 360 with ArcGIS Online and Enterprise, where we can have a shake hand, where we do work with engineering things, and we can have a GIS context also. So we already saw in our ArcGIS Pro demonstration where we have taken a BIM data. Now I can take this BIM data into my ArcGIS Online and Enterprise, and I can have a GeoBIM over there. We saw how it is in a scene layer, but now let us see how a GeoBIM is actually interacting. So let us move to the demo of the GeoBIM. So before that, I will just like to show how BIM 360 is looking. So in this BIM 360, we are having our building with all the engineering details. We can see everything, but as mentioned before, it is missing the context. We don't know where exactly it is on the ground or what exactly it is dealing with. So that's where ArcGIS GeoBIM is coming into the picture. So I geo-reference and I have shared that into my online, and you can see now it is sitting on my area of interest with the context. So this is one of the freely available Autodesk thing which we have converted as a sports complex to the Kendriya Vidyalaya Sihor, and we can see that is very much placing on the ground of the playground of this area. So as I mentioned, in this collaboration we get everything in one place. So in the left hand side you can see the issue reporting dashboard. Also from the management perspective or from the authoritative perspective, so if I am the person who is looking into this particular project, I can in one go I can see all the things like what is the status of issues, like this many answered issues are there, this many closed are there, this many are in dispute. Or I can even go to like what are the types, this many type design issues is more in my this particular project, so I have to recheck those things. Like this I can manage everything in one go. And even I can actually select one of my building content or building element, and I can actually check on a side by side manner what exactly is in the engineering document also. So whatever we saw in the BIM 360, that is directly opening in my GeoBIM application. So in the right hand side you can see how it is opening, and I can have all those things, all those controls, tools, everything which I saw in the BIM 360 is directly available within here itself. And now, as we mentioned, now the GeoBIM is giving us the context and the understanding how it is interacting with the environment. So here also we can have the options like how it is going to interact with the sun, position, date and time, how the shadow is going to be here. These kind of animated things we can do, and we can understand how exactly this new construction is going to affect my environment or my neighborhood. So in the similar way, I can have a shadow cast analysis also, where I can play with my time and how exactly the area of the shadow is going to be. And this will be very much important when we do a larger construction, and or suppose we are going to do a high-rise apartment construction nearby some water land or wetland, and you are seeing that in your shadow cast analysis, almost every time one or other building is giving shadow over that area or the water body. Now it is going to definitely affect the health of that water body. So this kind of analysis we can very much do with the GIS context, and we can understand these things. And pretty much more I would like to say, like, we can create slices, and we can also check what is inside this building. These kind of options are also available, where we can actually check what is the engineering things inside these buildings. That also we can check from the GIS perspective or in the GIS application itself. And as we are aware, in this engineering work, we do have things like the issue dashboard view. So we raise issues. What are the issues in this construction before doing the thing itself? So this we can actually do from the GIS context also, because when we place that on the exact lat log, some issues come into the pictures. Like if you zoom to this area, we can see the setback taken for this construction. It's not that great. It is very near to the road. So that is an issue which I found when I placed this BIM model on the GIS context. Now, when I identified this, I can actually raise that from the GIS context itself. So I can use this issue raising option, and I get this option, and I can select, okay, this is the location where the issue is, and I can select the type, and I can fill in the details, and I can submit that from my GeoBIM itself. So now it is going to the BIM 360, and there they can rectify this part in the design, or they can reconsider the location or the setback and all these things. So it is a kind of a handshake where we can have a through and fro interaction and understand the things and improve our workflow. So that was about the GeoBIM thing, and it was like, I know it was pretty much exciting how the interaction is happening. Now we did the construction and all. Now it is the time to make our buildings intelligent. Like that is the smart buildings. So that's where ArcGIS is offering us ArcGIS Indoors, where we can have indoor mapping, hybrid space planning, indoor positioning, and all these things. So let us quickly have a demonstration of the same, how exactly this is working. So in the first place, I would like to show how it is going to be in ArcGIS desktop. So in ArcGIS Pro, we have in a toolbox with Indoors, we get these indoor tools and indoor positioning tools, where we can actually convert our BIM data or CAD data into indoor data set, and we can create the network, the travel paths and everything. So here you can see my 2D data set of how it is going to be, and we can have a 3D conversion of the same, where we can have the 3D perspective of the same indoor building and everything. And later we can now take this to our web GIS, and where we will be able to utilize that in the web part with the interviewer. So here we can see in the interviewer, now the same 2D map is there. Now let us convert that to 3D and see how it is, how the building is interacting in the 3D. So here you can see all the indoor elements of the building is here, the pillars, the walls, the indoor things. We can have the schematic representation of different colors. This area is for this, the chairs, everything we can have. And we can have the option of exploring in this building, like these are the places and things, these are the safety equipments, or these are the particular things. I have this IMS room, now I can identify that on the map. And suppose I want to navigate, I have the direction option from here also. If you want to particularly get the direction to this IMS building, you can select the option of direction. And now suppose I want to travel from the UPS room, I can select the UPS room, and it will directly give me how to navigate through this indoor system, indoor architecture. So you can see we can have a audio option also, where it will say okay, go forward, then turn this right, and like that wise it will navigate us to this indoor system. So this we can have in our desk, like you are seeing that in my web. This we can have in the kiosks, in the malls, or in a big office building, or in a hospital. We can position this in a kiosks where the people who come there, they can navigate them themselves, or we can have it as a mobile application also where they can do a self navigation. So that's how ArcGIS indoor is, and this 3D in the ArcGIS indoor is helping us to do a self navigation and do these kind of things in an indoor way. We are now we have moved from the outdoor GIS everything to the indoor part now. So we saw the indoor GIS and everything. Now the next thing is indoor positioning system, which we mentioned. So in this video, you can see that how indoor positioning system or the blowed out technology is working. So in the right hand side, you are seeing the SVUC area, and the left hand side, you can see the indoor map of the same. So now that person is moving with the indoor positioning system mobile application, and he can actually see where exactly he is moving, and this is actually helping in the real-time navigation, so in an indoor environment. So this is actually possible with an installation of low fidelity Bluetooth devices or Wi-Fi devices, which will actually track our phone's Bluetooth or Wi-Fi when it is getting connected to that next Bluetooth pillar. So likewise, we can do a self navigation and navigate through any big conference area or office or a hospital or wherever we want to deploy the same. So that is about ArcGIS indoor and indoor positioning system, and this is how it is helping us. Now we have seen the specific things and all, and we were missing out on something, our web application and 360 VR. So let us see a demonstration of the same. So here we can see the digital transactions in India, and we are seeing that in a 3D perspective, how exactly each state is having performing in their digital transaction. We can have different options like how we do in our 2D maps. We can have the informations in pop-ups, and we can actually have a better view here in this 3D form, and we can also see district wise things here. And as usual, we have integrated our map, these charts and everything, and we can have filters also. So likewise, we can now create a 3D application with our experience builder, or we can create 3D dashboards also. So likewise, we can create out of box configurable web application, or we can always use the JavaScript customization option and do the customization on the same. So now let us see 360 VR that we mentioned in our city engine, or we can actually convert any scene layer also into 360 VR. So the 360 VR is going to help us to get a virtual reality experience. So this is a bird eye view of an area of Mumbai, where it will be how this was from the perspective how it is going to look after 10 years to accommodate more number of offices, residential complex and all. So when we now we are seeing it in a web window, but when we actually use a VR experience glass, we can actually take this into the VR experience glass, or in the mobile we can put that in the VR experience glass, and when we move or when we turn this kind of simulation, we will be getting the actual experience how my GIS based planning or modeling is going to be looking like in the actual world when it is getting done. So this kind of a VR experience also we can directly create once we do our 3D modeling and everything in City Engine. We can directly convert this and we can have this ready. So that was about the 360 VR experience and the web application. Now we have seen many things, like starting from the data capturing, how it is going to be processed, or what technology we can do help us for the processing, and what all other attributes in the ArcGIS system is going to help us to build our 3D models for our digital twin. So basically, as we started with digital twin, what it is like, it is the real world models, which will be our 3D models and the 2D layers and everything coming together with the data integration, and where we will be having the real-time data And on top of that, we are using the ArcGIS systems and other environment for visualization and analytics. And we also do the scenario management and planning. So this is how a digital twin is going to actually help or do us to do our accelerated and efficient sustainable planning and green towards the green future. So that was about the digital twin. So now let us see how it is going to be coming together. So here you can see the city of Boston, where they have used ArcGIS Reality Engine, and they have created this mesh of the city, which you can see. So here we are seeing a very realistic experience of the city on the our web experience. And you can also see, as we mentioned, it is not just the 3D models. We can see the other attributes like these are the location of the petrol pump. And here now we are seeing a BIM model integrated to our digital twin, which is a building information model. We can have the inside view and all the other things. So this kind of a complete integration will be the exact digital twin is going to be. Now, as we mentioned, it will be not just one type of data, it will be multiple other types. So here we can see building use types represented with different colors, and the attribute like what is the year of this building, construction year of the building. And zooming in, we can see how the sewerage system in that particular area. So here in this area, we are showing what is the underground sewerage system, where are the manholes are. This we are showing for the representation. We are showing that from the upper perspective. And moving on, here in this building, we can see how exactly this building is from the inside, how exactly this building is used inside with the different color perspective. Okay, this color is for this particular hotel, is the space use type of this particular color. This kind of information also we are getting. And as mentioned, the main important thing, the real-time data integration. So here we are seeing how the real-time data is also integrated to our digital twin, with a different severity of the things. And also digital twin is very much usable in our planning and designing. So here we can see the thing we planned in ArcGIS Urban, and on top of that, city engine is giving us the models of trees and everything, and the game engine is used to simulate the same. So that was all about the 3D across ArcGIS. And thank you for everyone.